Good morning. Last time we saw what is counter, how it counts the clock pulses. Okay. Then what is the relation between number of flip-flops and the number of output stages. Maximum count is 2 raised to n minus 1. If number of flip-flops are 4, then there are total 16 stages. And maximum count is 2 raised to n minus 1, that is 15. Okay. Two types of counters, synchronous counter and asynchronous counter. In synchronous counter, clock is parallelly applied to all the flip-flops, and in asynchronous counter the output of first is used as the clock of the second. Okay, so this is the counters primary theory. Then we are going to see the 4-bit binary counter. Okay, so in this diagram we use JK flip-flops. Okay, so these JK flip-flops are in toggle mode. How it toggle in toggle mode? Because J and K commonly connected to logic level 1 or high state. Okay, so that's why this is called as T flip-flop. Okay, so this is T flip-flop, and this is a 4-bit, so that's why each output of flip-flop is used as a one output. So this is the most significant bit and this is the least significant bit of the output binary. Okay, so you have to apply a clock to the first flip-flop, that is which has an output that is the least significant bit. So LSB, okay, and this is the MSB, most significant bit output. Okay, so you have to apply a clock here. Okay, so when we apply a clock to the first, it changes the state, and whatever the change is applied as the clock of the next flip-flop. So that's why it is called as asynchronous counter. So output of the first is used as the clock of the next. Okay, so similarly, so it is called as asynchronous counter. So here this is the clear, we know the clear state, clear input. If we apply a clear input, the flip-flop gets cleared. Flip-flop gets cleared means what? Output of all the flip-flops becomes 0. Q equal to 0. So Q equal to 0. So if we apply a clear input, the output of all the flip-flops becomes 0. Okay, so this is the switch. If we apply, so all the clear inputs are active high states. Active high means if we apply high, then these flip-flop gets cleared. Okay, so this is applied to this press switch and plus. So because we have to apply logic level 1 or a high voltage. Okay, so that when we press the switch S, the 1 is applied to all the flip-flop clear input, very short duration of time, and the flip-flop gets cleared. So initially the flip-flop gets cleared if we apply this input. Okay, clear. So let us see the timing diagram. Timing diagram means you are going to see the states applied for the input and output. That is called as a timing diagram. Okay, let us see here. So we are going to apply a clock. Okay, so this is a clock frequency applied to the input of the LSB JK. LSB means least. The output of that flip-flop is having least significant bit output. Okay, so once if we apply a clear input, all the output of the flip-flop gets cleared. Okay, So here QA becomes 0, QB becomes 0, QC becomes 0, QD also becomes 0. Okay, so this flip-flop, when we apply a clock to this flip-flop, so J and K both are connected to 1 so that it gets toggled. Okay, so when we apply a clock means it is a negative age triggered clock. So it is most important point in this counter is that all the clock inputs are negative age triggered clocks. So every transition at the output of this flip-flop are at the negative age, so that we are going to mark the falling age of this clock input. Okay, so this is the most useful thing to draw the timing diagram, is you have to mark the falling age of this clock. Okay, so you have to mark this first. So when we apply first clock, then this gets triggered because J, K both are equal to 1. So this is the, let us see the at the arrival of the first clock what will be happen. Okay, so the arrival of first clock, the first flip-flop get toggles and its output changes 0 to 1. So this positive change is applied to the input of the next B flip-flop. Okay, so this is a rising edge, so there is no change at the output of this B flip-flop, so there is no change. This is applied to the clock of the next, so there is no change. Okay, so at the arrival of second clock, what happens? Again, because J and K both all the flip-flops are having JK equal to 1, so these are operated in as a toggle T flip-flop. Okay, so at the falling edge of the second clock, then again Q toggles. Okay, so this falling edge now is applied to the clock of the B flip-flop. So JK equal to 1, already it is connected, so this get toggles. Okay, so this get toggles. So this rising edge is connected to the C flip-flop. There is no change because it is a rising edge, because all the flip-flop are having a clock with a negative age triggered. Okay, so at the arrival of first clock, what is the output? 0, 0, 0 and this 1. So it means that equivalent of this 0, 0, 1, 0, 0, 0, 1 is 1. So it indicates that first clock is arrived and it gives the output 0, 0, 0, 1. It is the first clock. And what is here at the second clock? So here at the second clock, so here is also 0. So here is 0, here is 1 and here is 0. Now output is 0, 0, 1, 0. Okay, it is 0, 0, 1, 0. So output of this flip-flop is increased one step. Counter output of the counter is increased one step. Okay, so at the arrival of third, so at the arrival of this third, so this flip-flop again gets toggles. Okay, so this positive change is applied to the clock of the next. So this positive change, so there is no change. So there is no change and there is no change. So output is 0, 0, 1 and this is 1. That means output is equivalent to 3. So third clock is arrived. So at the arrival of fourth clock, what will be happen? So at the arrival of every clock, this first flip-flop gets toggled because it is directly connected here. So it gets toggled again. Okay, so this is falling edge. It is applied to the next. So again it is the falling. Okay, so now this falling is applied to the input clock of the next, so it gets changed. Okay, the rising edge, this rising edge is connected to the third, so there is no change because it is rising edge. So output becomes now 0 1 0 0. It indicates that 4 0 1 0 0 is 4. So similarly at the arrival of this fifth, so it gets toggles. So there is positive change, so there is no change, no change, no change. Okay, so at the arrival of this one, it get toggles. As it get toggles, so it is applied to the next clock, so it is falling edge, so again it toggles. So here is no change, so it is rising edge, so here no change, no change. So arrival of this, it gets toggles, rising edge, no change, so no change, no change and no change. So output is now here 0 1 1 0, it is 6. So here 0 1 0 1, so it is equivalent to 5. Okay, so like that, so at the every arrival of first flip-flop gets toggles, and if there is falling edge, then next flip-flop gets toggles. If it is falling edge, the next flip-flop gets toggles. Okay, so where is that? Okay, so here now 0 1 1 1. Okay, so here falling edge, so this falling edge, it gets toggles again. So now it becomes 1 0 0 0. So then at this stage again it changes, positive change, so there is no change, no change, no change. Okay, so here it changes, negative edge, it changes toggles, so no change, no change. So here now again falling edge, rising edge, no change, no change. So here 1, so here 0 1 1. Similarly, so here falling change, then it also falling, so it changes, 1 remains, 1 1 0 0. So like that you have to continue up to 15th clock. Okay, so you have to continue up to 15th clock. So up to 15th clock, when we apply a 16th clock, then again you will get that all the output gets 0 0 0 0. Okay, so this is a 4-bit counter. Okay, so if you observe that here at every falling edge of the clock, QA toggles. Okay, so QA toggles, so here QA toggles, here QA toggles, here toggles. So at every falling edge of this clock, QA toggles. At every falling edge of this QA output, QB toggles. Toggles means changes the output. So at the every falling edge of this QB, QC toggles. Okay, so at every falling edge of this QC, QD toggles. Okay, so just you have to, there no any bothering be here, because just at the falling edge you have to change the next output, at the falling edge change the next output. But keep in mind that, so this D is most significant bit and this QA is least significant bit. Okay, so just you have to keep in mind that. So if you change this LSB MSB, if this QD and QC if you interchange, then totally gets wrong, you get 0 marks. So be careful. You feel that I am writing very well, but actually because of, in case of logic, it is totally wrong. So you have to keep in mind that for LSB you have to apply a clock. This is the most significant bit. You have to write LSB first and then write MSB. Okay, and at every falling edge, just you have to go on changing the next. Just you clock, write down the clock and at every falling edge just toggle the QA, at every falling edge toggle the QB, QC and QD, like that. Then truth table of this counter is very simple. So input is clock and output is D, QD, QC, QB and QA. Okay, A is the LSB. So at the 0 clock, if you apply a clear state, if you press the clear, so you will get output is resetted. Okay, at arrival of first clock, so you will get 0001. So this is equivalent of the number of clock. So that's why it is a counter. It counts the number of clock pulses. So at the second, it becomes 10. Okay, at the third, it becomes 11. At the fourth, it becomes. So similarly, it continues up to 15th. At the 15th, you will get 1, 1, 1, 1. Okay. So at the 16th, you will get again 0, 0, 0, 0. It is resetted at the 16th. So how many? So according to this equation, so there are 4 flip-flops. Okay, so 4 flip-flops. It is count 2 raised to 4, that is 16 states. Okay, from 0 to 15. So up to here only it count 16 states. And according to the equation, 2 raised to n minus 1, that is equal to 15. So this is the maximum count. Okay, this is the maximum count, that is 1, 1, 1, 1. So it is equivalent to 15. Okay, so this is the maximum count. Maximum count is 2 raised to n minus 1. So number of flip-flops are 4. 2 raised to n, number of states are 16. From 0 to 15, the total state becomes 16. So 16 number of states are counted. 2 raised to n minus 1 is 15. So maximum count is 15. Okay, so this is a 4-bit binary asynchronous counter. Why it is asynchronous? Because clock is applied to the first flip-flop input, then it applied to the next flip-flop's clock. Okay, so this is asynchronous. So let us study this. Very simple. If your logic is cleared here, and it is very simple to explain also. Just simple, what is connected here, where clock is connected, and how it changes the state. As QA changes from 1 to 0, then it toggles B. Okay, simply just you are going to explain this, how it works. Okay, how it is connected. So this is the truth table of the counter. Okay, let us stop here. So go on practicing with this. Very easy topic and interesting also. Okay.